Well, hello everyone. Welcome back to Adrian's Digital Basement 2. On today's video, hopefully something quick. This is my IBM PC 5150, the original IBM PC from 1981, and this is a Rev A model. So this has a motherboard that has support for only 16 to 64K on the motherboard. Hard to believe IBM released a PC that could only have 64K of RAM, although it has ISA slots. So I think the BIOS on here supports up to 500 and some amount of K, 546, 576, I don't remember the exact number. Now what's going on with this machine is I went to go use this for a recent video on the main channel where I did the BIOS hacking to make the boot speed much faster, and I went to turn this thing on, and while it turned on and I saw video output and it even seeked on the floppy drive, it would not boot and I got a parity error. So we have some kind of a RAM fault on this thing, and I don't know because the parity error checking on these IBMs is useless. It just said parity error 2 without telling me where the bad memory is. So I think, well, in this video, I want to figure out where the bad RAM is and get this machine operational again. So first need to get this hooked up. So I have it hooked up to power, and yep, everything's hooked up, and RGB to HDMI is going to display the video output. Let's turn this on. Luckily no tantalums go, because these are famous for blowing tantalums. That recently just happened on my 5160 on the hard drive controller card. It kind of smoked out the entire basement. There's our flashing cursor. This of course has the stock ROM in it. In fact, oh, parity check 2, there it is. So it didn't actually go very long before it gave us the parity error. So it kind of implies it's not seeing the extra RAM that's on the RAM expansion card that's in here. Now, I have a One ROM here, which of course I showed off a lot in the video where I was doing the ROM hacking. I would like to replace the ROM on this with something else, and it's good to have the ROM or the One ROM, because the problem with the ROMs on the 5150 is they're mask ROMs, and you can't just put an EEPROM on these. I'm pretty sure you cannot. So the One ROM will totally work in this thing, and then I should be able to replace the ROM and get something better than this on it, so we can have a faster boot process, for instance, and have less annoyance than that. All right, first thing I need to do is shut the power off, and the fan in here is so loud, but it's the original fan. It sounds like a hard drive, actually. I probably didn't come across on the microphone. Anyways, I need to take this thing, take the cables out the back and open this thing up so I can figure out what exactly is going on. And as usual with IBM stuff, it is so heavy. Let's get the camera closer in. This is the Rev A version of this computer, as I mentioned, and one funny thing about it is it only has 2 fasteners that hold the lid on. That's it. Nothing on the top edge at all. IBM later added fasteners along the top, and that kind of gives you an idea that it is the later version. And I think something about stuff happening here kind of gives you the idea that it's the early Rev A model as well. Now, I bought this computer from a local person. This was several years ago, and they had highly modified this computer. So in other words, it had a hard drive and none of the original cards were in here. It did have the original motherboard, and that's the good thing. And then the case was original, although it was in extremely rough shape, meaning this had been exposed to a ton of moisture. So there was actually quite a bit of corrosion on the lid, on the, the bottom part of the case. So I had to do a lot of work cleaning that up, and that was all in the early days before I was making a YouTube video. So there is no footage of any of that work. Luckily, the power supply is original, motherboard's original, case is original. And actually, I think I swapped this top cover, not the front faceplate, because that's plastic and that goes with the rest, but this top metal cover was all rusty. So I think this one came off of another computer that I got at some point, which is good because this machine kind of holds a special place in my heart. I really kind of like this computer, and yeah, actually now I think about it, it has one of the original drives, but this one's not. And I actually have another IBM drive, so I could put the double disk drive configuration in here, but I don't know. For now, I'm just gonna see what's wrong with the RAM. That's the order of business right now. All right, taking a look inside. So double floppy drive, as I mentioned. I do have an XT IDE card in here. It's this one, and that's an early one that I bought. I make them now, but I bought this one. So it doesn't even have a bracket. So it's sort of floating around in there. But what is in here is this toggle switch. That's what this wire is going to. And this makes its way over to the video card. Now this doesn't have an original IBM CGA card in here because while I like those, I don't like the flicker and the snow so much. So the one that's in here is a normal CGA card, but it actually is monochrome, MDA, and CGA, and there's a jumper to select between the two. And that's what's going on with this toggle switch, is it allows me externally to switch this thing into mono mode. So if I want to use the 5150 with this, which of course was the monitor I got with it, I can. Or I can use CGA. I have a network card. Then I have this, which is the floppy drive controller, the original floppy drive controller I might add. Yep, XTIDE. And then this large card, which has a battery on it. I think it's an AST RAM page. And this has the expansion RAM that brings this thing up to the full amount of memory. So I suspect our problem probably exists on this card. So I got to get that out. And then we'll power the computer back on and see if that RAM error went away. And part of the problem is here is like, if there's a memory problem on this machine, like it's not telling me where it is. It just gives us that parity error, which is very bad. And wow, that came out really easily. I'm concerned, let's get that into focus so you can see it. I'm concerned this was maybe just not installed properly. So it's a Mega Plus, AST Mega Plus with a Mega Pack. Okay, and the wrong size battery on there, so that might be dead. And this memory is all soldered down, so if that's bad, but first things first, let's just pop this down like so. We'll see if this thing works. By the way, looking at this, I don't think this is actually the original power supply. So me trying to save that fan, this is a 120 volt fan, so it spins up very slowly and it's kind of got noisy bearings. Not sure there's any reason why I would keep that. If you know what an IBM 5150, an early 5150 power supply looks like, does it look like this? I somehow doubt it. This was probably replaced at some point to handle the hard drive that was in this thing. It had dual 5¼ inch half-height floppy drives and a hard drive on the other side and hard drive controllers, and had a monochrome card. I got the 5150 with this machine, and yeah, anyways. Okay, enough talking. Will we still get the parity error? That is the question. So as is typical with the, oh, okay. Why are we getting that error? What was that error? Not even sure. I don't think it's gonna be able to boot DOS though, because it's gonna try to load like MS-DOS 6.2 or whatnot, and yeah, that's not gonna work. It had a 201 error. I'm pretty sure a 201 error on these machines has to do with the RAM. And I can't even push Control-Delete. Okay, well, this particular problem is a perfect excuse for me to install the One ROM, because then I can flash the the dead test, RAM test onto this thing, which will easily tell me where the RAM problems are very quickly. And I can plug the card back in as well, the RAM card, and it'll test that as well. And no dumb parity errors. So let's turn that off, and I got to figure out how to get the One ROM into here. All right, you can kind of see that below the floppy controller here are the basic ROMs. There are 4 of them. And then there's an extra ROM chip that's partially under the floppy drive, but I can get to without taking it out. That is going to be the system BIOS ROM. And then there's a blank spot over there. That's for an option ROM. And I'm going to have to go look up exactly what the pinout on these, because I was under the impression that these were going to be similar to 2364, so 8K ROMs, but in a 24-pin package. And yeah, they are 24-pin package. So that tells me that these are the equivalent of, sorry, just move this cable out of the way. These are the equivalent of 2364. So that means One ROM is going to have to definitely be used on this thing. You can't just put an EEPROM into these. It's very much like a Commodore 64 and the kernel ROM as a good example. It's 8K as well, and it's like a 2364. Now I actually can program an EEPROM for this. I have to get out my data IO to do it. I have some special proms that would work in there. I think it would work in there. But the easier solution is just to use the One ROM, since this thing obviously can emulate all sorts of things. This is a 28-pin One ROM, so this is not the one to go in here. I have to use a 24-pin One ROM, which if I can get the camera to focus, there it is. That's the 24-pin One ROM. Now it has a couple extra connections here called the X1, X2 signals. And I could run that over to the chip select line of that empty socket, for instance, and then I could actually populate that using something that's on this. Meaning I could flash the EEPROM that I want for the ROM. Oh no, I can't get that in. And oh, I thought it was hitting the floppy drive. It's actually, it will clear the floppy drive, so I can get that in there. Anyways, I could have that be the system ROM, and with that flying lead over to that socket, I could have an option ROM for something else. For instance, a GLATIC, which is a clock driver, or GLADISC, which is a disk driver for high density drives, for instance, or whatever, some other option ROM could go right on the motherboard, and this can serve both purposes. And this actually has the ability to serve as up to, well, I think it can do 3 ROMs. So I could replace 2 of these basic ROMs, but there's no reason to. Those are all working as far as I'm aware. All right, let me get that thing into the socket. I got to move the camera to do it. Now, speaking of the 5160, I just posted this to my Bluesky. Yeah, basically, I was going to button that computer up after I was done filming the video on the ROM modification, and I put the hard drive controller back in because I'd taken that out for doing all the demonstration stuff in the video. Put the lid on, screwed it together. I thought, oh, let me just test this real quick, make sure the hard drive's still working, because it's an MFM hard drive. I haven't used it in forever. And sure enough, I turned it on, the power supply was making weird noises, and then a bunch of smoke came out the back, and I opened the lid, and yeah, it still smells down here, and this was hours ago that this happened. So what happened is this capacitor on the hard drive controller decided to let go. So I ended up taking all the tantalums off, and well, yeah, it works fine now. And actually the hard drive still works too, booted up and everything. But that was kind of gross, and the smell, I mean, that let out so much smoke. So I'm always kind of worried that's going to happen on this machine, since it has happened, I think, on this, or maybe it hasn't. I can't remember. I think it did. Pretty sure one of the 12-volt rails or minus 12-volt rails has a tantalum, or not a tantalum, it has an electrolytic cap on it. Anyways, okay, One ROM. Just as a refresher, in case you hadn't watched that other video, the One ROM is a Raspberry Pi RP2350 ROM replacement, a ROM emulator, basically. So the Raspberry Pi Pico on there, it's a microcontroller. You flash it with a USB-C cable, and it's able to do all this awesome stuff, and it's very inexpensive, and it's totally flexible. That's the best thing about it, is you can replace mask ROMs, you can replace all sorts of different types of chips with these devices. And there's a version that's well, there's like a 28-pin version, there's a 40-pin version, there's a 32-pin version, and there's a 24-pin version, which is the one that's in this machine right now. Now, what I need to do is I need to find the web programmer, which here it is right here. So I should be able to connect up to the one that's in this machine. The machine's off. And oh, this looks like it's programmed with some kind of a Commodore 64 thing. This is was sent to me by Piers, who's the one who came up with this whole thing. He sent me several of these to play with, and yeah, thanks very much for that, Piers. And I hadn't used this one yet, so yeah, this is running kernel, basic, and character ROM. Because remember, as I mentioned, that one 24-pin module can run as 3 ROMs. I think it can do even more potentially, but right off the bat, it can run easily as 3 different ROMs. You just run the flying lead from those X pins, there's 2 X pins, over to the chip select of the other 2 ROMs. So one ROM can be installed, one of these 1 ROMs, and then it can emulate all of the ROMs. And the wild thing is, plus 1 more in 4 sets. I think what this is saying here is that you can have multiple versions of these sets of ROMs as well. So you can have multiple character ROMs, multiple basic ROMs, multiple kernel ROMs. You could have like Jiffy Dots, you could have regular, and you could switch, not real time, but like there's different inputs on here, so you can put a toggle switch and switch when you power it up. Either way, what I need to do is deselect that, automatically filled in this. I need to select the dead test ROM. And what the dead test ROM is I've made a video about this in the past, but you might have missed it. It's the XTRAMTEST, and it's written by my friend David Giller here local in Portland. And we're up to 0.2 actually, but it's from a few years ago. Anyways, what it does, it tests all the RAM. It doesn't even need working RAM to work. So the computer could have 0 RAM and it'll still work because it uses the CGA card memory as a little bit of space for stack stuff, things like that. And it will very quickly tell you where your memory errors are. And if you have holes in your memory, like say, part of the RAM's not working on this machine, well, then I'll be able to tell that very quick and very easy. So with the One ROM, I should be able to select that, and I think I have it floating around here. Let's see, XTRAMTEST. Yeah, I downloaded it for system testing on my other PC. I didn't really show that in the video though. Anyway, so we selected that. Now I have to pick the ROM type, which my assumption is it's that. What I don't know is for the IBM, the chip select logic. I'm going to just assume it's active low, but it can be active high. So if I try this and the thing doesn't work, I'll try the other mode. So you hit build firmware, we hit program, and that's it. That ROM is now programmed with this dead test thing. So I've unplugged the USB. So we are ready for testing. Okay, so RGB HDMI is still hooked up. The RAM card is out. So I just want to make sure this works. And the original ROM is sitting right there. So here we go. Okay, one ROM is on, but we get nothing. Unless I'm on the wrong input. No, there we go, that's right. Okay, so whoops, knocking things over. Okay, so I think the problem is the ROM is just not working. That's fine. So we're just gonna go and I'm gonna plug this USB cable back in. And I'm gonna change this to active high. Let's try this. We have to build it again. Now program it. Okay, so yeah, it's XTRAMTEST that's loaded in there. I guess we can look at the firmware details. Oh, this is like the JSON that's actually the configuration. So you can like alter the configuration as you need to. I'm just looking at this chip here. Yeah, this has got to be a 2364. It's just got to be. Anyways, okay, well, let's try this again. So let's turn it on now. Oh, well, that's a problem because I can't do that while the USB is connected because that puts it in programming mode. So let's try that again. Nothing. A little hard to see. Let me move the computer over so you can get a better look at it here. There it is. It's in there. I really should just, let me take this floppy controller out. I was trying to work around it and it was in the way, so I couldn't really push the thing down properly. So let's get that out. Yeah, I wonder what's happening here. I hadn't tested this version, the 24-pin one, inside this PC, but let's make sure this is in all the way. Just unplug that for a second. Incidentally, it looks like I've had to change out some of the RAM on here. We already have a couple replaced chips. These are all Motorola chips, the ones that are in sockets, and then what's in the board soldered, this first bank, this is 16 kilobytes. Those are AMD chips, and then we have parity RAM over there. So let's make sure this is in all the way. Yeah, it's in there. So I guess I need to look up the pinout of these sockets. Luckily with their schematics, and we need to compare to the 2364, see if it really does match that. All right, we're on the fabulous -0degrees.net. Generation of chip select for the U33 ROM. U33, I think that's not what we are on right now, or is it? Yes, that is actually what we're on. U33 is that chip. CS pin of U33 will be low when all the following is true. Okay, pin 20, so there it is. Okay, here's a 2364 pinout. So address line 0 is pin 8, 7, 6. Yeah, this all looks correct, all the way to 1, so right there. And then 8, address line 8 is pin 23, that matches. Address line 9 is 22. 10 is 19, that's correct. 18 is 11, and address line 12 is pin 21, that matches. Chip enable, pin 20, and chip select, same thing, and we know that it's active low. Data line 0 is pin 9, and then we have 10, 11, 13, because pin 12 is ground. So 10, 11, 13, 14, 15, 16, 17. 10, 11, 13, 14, 15, 16, 17. Oh, yeah, I mean, it totally matches. So it's just 2364, and it's active low. So what's going on here? So I'm going to reconnect the USB cable so we can see exactly what's going on here. So I know it's wrong now. And XTRAMTEST, I mean, I'm pretty sure it should work in, I've never tested it in a 5150 actually, now I think about it. I mean, I don't know, it's got to work. I would think it's got to work. 2364. So we program this and it says complete. And I have to unplug the USB cable because I can't have that plugged in at the same time as the one ROM. It goes into programming mode whenever it's connected to a host. Otherwise, it's fine. And, I mean, we saw it working, meaning like the computer works. But this XT thing is not working. Okay, you know what I'm going to do? I think I'm going to go download the ROM. I'm going to download the release of GLABIOS here for this machine directly, just the stock build, this one. And I am going to, yeah, it's got an 8088 in here, and I'm going to load this onto here, and we're going to see if this works. Maybe the XTRAMTEST doesn't work. I mean, it's totally possible. Okay, so it's the P ROM, active low, 2364, so that's all good. We plugged in. No, not plugged in. So I plug the cable in. Okay. Now I hit program. There it is. And I think if we look at this, there it shows the ROM. I always have to remember to unplug the One ROM before I test the machine, otherwise it definitely won't work. Okay, here we go. No. Okay. Well, this is very curious. Very, very curious. I have one hunch that I'm going to try. On the top of this, there are a couple positions for bank switching. Just so you can see, I grabbed another one of these and see it says bank select. As I said, I haven't used one of these 24-pin ones yet, and the 28-pin one I was using for the IBM XT doesn't support this whole bank switching stuff. Okay, here we go. No, that didn't do anything. And let me try these other banks just to see what happens. Nope. None of them seem to do anything. And I know this is working as in getting power. The red light's on brightly. If it's on dim, it's hooked up to USB. All right, well, all I can think to do is take this out. Let's see if I'd like damaged a pin maybe. It was really hard to get in here. I mean, there it is. Nothing is damaged. Although, what's that extra little like blob of solder that's on there? Don't think that's going to cause a problem, but and I think these were all tested. This had the Commodore 64 stuff loaded onto it. I assume that was a test by peers. Okay, I just removed that little extra blob there. Not that that was making any contact. So everything's good. Socket's fine. That's in the motherboard. Let's move this so you can see it a little bit better, but it's focusing on the disk drive there. Socket's fine. Notches at the top. This has a little pin 1 indicator on the top there. Let's try this again. I mean, the light was on, like I said, so it was getting power. If this thing's in the wrong way, it's not going to get power, obviously. Push this down into the motherboard. Yeah, you got to push really hard. There we go. It's in there. All right, let me try this again. This is a bummer. This is not working. So you see the light's on, but we have nobody home. I suppose what I should do is try a different one, just in case somehow this one is bad, damaged, I don't know. Okay, let me get this one in the board. Oh gosh, it's so hard to get these in. There we go. I will need to program this, obviously. Plug that in. Cable fell on the floor. We will have to reconnect because this is a different one. Yep, it's loaded with the Commodore ROMs again. Incidentally, you can see here, like CS1, stay active low. There's no CS2 or 3 on this type of ROM. This can emulate ROMs that do have those other chip select lines. Active low, ROM 2364, ROM 2364, and a 2332. That's the character generator on the 64. And active low, active high. Yeah, so it uses a slightly different state. This is one of the other profiles. Oh, dead test. So dead test is actually on here. So this is like one of the other banks. How is this defined? ROM sets. So there's a ROM set. ROM count 1, ROM count 1, ROM count 1. I'm going to load GladBIOS, the 8P, which is the one for this machine. Active low, chip select 1 logic. We already know that that is correct. 2364, latest firmware, build, program. Complete. And we turn on the computer. Okay, what's going on? That's weird. So this one, let's get the camera a little closer. It's in correctly, but look at the power light. What the heck is going on with that? Let me get it out of there. Maybe a pin got bent or something. It was flashing. The chip enable line, or sorry, the power light was flashing. Not a good sign. Nothing's damaged. All the pins are correct. So what the heck is going on? Definitely pin 1 is up there, which is matching with the top little mark on there. So I'll get that back in the board. I mean, I don't know what's going on. This is so weird. Okay, there we go. Let's see if it does it now. Yeah, I don't know what's going on there. That does not seem right. And the other one, this one was not doing that. Okay, I Guess let's see if this thing is somehow damaged. Can I program it? Yeah, it sees it. I just loaded this right off of it. I'm not experienced enough to know what is happening here. I'm going to try like the XT-ROM. It's the wrong ROM for this computer, but I think it just still mostly initialize it. And we got to pick chip select active low. We'll build this. And then we turn it on, unplug the USB first. And it's doing that weird blinking. Let me shield the light so you can see that a little bit better. Completely clueless here. What's going on? Don't know if this one is bad or what. But the other one had just a solid power light. I'm going to put the EEPROM back in, or the original ROM, I mean. I may just have to go and program a ROM on my EEPROM programmer. Uh-oh. Oh, yeah, look, it just took a while. But there's our cursor and our error. So the computer still works? So there's like some kind of incompatibility, I guess, with the One ROM and this machine. All right, so I happen to have one of these, which is a 2364 adapter for EEPROMs, and I can use this on this computer to, if this fits. Oh, it doesn't fit. It doesn't fit under the disk drive. Okay, I can't use that. I thought I could use that. I'm gonna look, I think I have a ROM program for this. Yes, I do. I do. Okay, here we go. Check this out. So what you see here is one of those programmed EEPROMs, and these are diag ROMs. I don't know if this is the RAM test ROM or which one this is, but this is one of the 2364 compatible EEPROMs that I have that I can program on my data IO. So let's pop this in and see what happens. Yep, it's not the RAM test, but it's this diagnostic ROM. Okay, well, that kind of tells me that I guess the one ROM, well, one of them might be bad, I don't know. And the other one, oh, doesn't seem bad. The light's not flashing, but it does not seem to do anything. I can't get it to work on this machine. These chips that are in here, this works in a Commodore 64. I can put this as the kernel ROM, it totally works perfectly. So it's compatible with this, it's compatible to 64. That's the chip enable as low. Oh, this thing is going to error out. This RAM test on this thing, by the way, sucks. This is like the old landmark test, and it's not good. It is not good at all. So I got to hook up the floppy drive because it complains about the lack of floppy drive before it even gets to the RAM test. I think I'm going to have to break out my EEPROM programmer, and I'm going to have to program. I'm going to have to program one of these ROMs with the XT RAM test, because I need that to really tell me quickly where the RAM problem is. I don't have any other issues with this computer. I don't need all these other tests. I just need the RAM test to work. And the RAM test on this ROM sucks. Totally sucks. Now, I suppose what I can do while this thing runs its diagnostics is I can grab a Commodore 64 here and I can test to make sure. It's trying to read the floppy disk. I can check to make sure that these ROMs do work by just hooking them up in the 64 here. Got the one ROM into the 64 though, at least. It's doing a RAM check right now. Could still be useful for, I suppose, telling me where the bad RAM is. I don't know. I really need to get the other one working though. Let's see if we get the flashing light. That's what we're looking for here. So let's zoom in on this. Turn this on. Yeah, it's still doing that weird blinking. So that doesn't seem correct exactly. It doesn't see a RAM problem. What is the RAM error? Okay, I'm done with this ROM. This ROM is so bad. I'm firing up my EEPROM programmer because I got to get to the bottom of it, because I remember struggling with this ROM in the early days, which is what prompted me to talk to David about programming the XT RAM test, because I just was so annoyed by this RAM test being so useless. And I'm going to program the ROM with some kernel ROM image, because that's in the kernel ROM socket, because I want this thing to actually operate as the kernel ROM. I already lost my USB cable. Here it is. I am flustered right now, and this is just how it goes sometimes, everyone. Looks like we have pre-built images for this particular device. Is it connected? Let me reconnect. Okay, there it is. This is the one with the weird flashing light, by the way. I think I can just pick stuff here. Yeah, okay. I don't want the set. I just want a single ROM. Yeah, it seems like all of these are sort of either banks. I don't know. This doesn't have the headers on it, this one, so I can't use the bank stuff. I'm not sure what that means. I will just load the image myself. Pretty sure I have a whole bunch of kernels. There it is. That is the stock kernel right there. 22703. So we're going to load that. I'm pretty sure it's active low. Build firmware. Program. I'm just switching back to RetroTink. Yep, there we go. Of course, RetroTink is slow as molasses. Yeah, black screen. That does not work. I should have tested this first with my original kernel ROM. So I'm going to do that real quick because you know me, things can break. Like this 64 could be not working for some other reason. So I need to make sure that it works. Okay, there we go. That's out. Put the Jiffy DOS one I had in here back in. Okay, Jiffy DOS or Jaffy DOS. It's also this waiting game. Yeah, okay. Machine works. Oh, it's running in PAL mode as well. Interesting. Cool. Working 64. Without the pins, that was not working. Let's try this one. This was the first one we tried in the IBM. This one didn't have the weird flashing. So we'll just quickly program this with the kernel ROM. Okay, it's programmed now with the kernel ROM. Turn this on. Black screen. Okay, so I'm doing something wrong, obviously. Let's just check this out again. I mean, maybe I did something wrong. So there it is, Fire 24E. That's exactly what this is. Firmware versions. Let's upload a ROM again. We'll do the kernel ROM again. 2364. So I'm not doing that wrong, right? And active low. And we build. And we program. It's done. And we can even look at the firmware device details here. It says how it's set up. 2364 active low. CS2 and 3 aren't used, and it's loading 901.227.03. That is the kernel ROM. So cable's unplugged. Turn this on. Black screen. Okay, so Piers sent me more of these, so I'm going to try another one because I think I'm doing everything right. I just don't know. So this one doesn't have the weird flashing light. This is the one that has the flashing LED on the power LED, whatever that means. Like, I don't know if that's like an error code or something. And then the one I just took out is that one out of the package. I have 4 of these to try. So we'll try this one. There we go. Okay, let me turn it on. Okay, we don't have the weird flashing LED at least. See, it's just solid on. Oh, and this one works. So are these bad? I guess these are damaged. Did they get damaged by the IBM? I don't know. I just do not know. Let's try programming something into this. And the only thing that really happened there is I connected one of those or both of those into the IBM, and then they both seemed to stop working. So does the IBM kill them? Good question, right? All right, so this is programmed exactly like the other two were. So this is the default configuration, which I guess it comes as a kernel as in the first position. Let me just program this now with the kernel ROM, which is already set there. Active low, which is exactly how it was in the JSON file. We'll build, we'll program, and I will turn it on. And it works. So these other two must be damaged. And I don't know if it was the IBM that did it. Yeah, it feels like they got damaged by the by going into the IBM. I don't know how or why. What I'm going to do is I'm going to get a little paint marker here so I can mark these. I'll just put a dot on the Raspberry Pi Pico chip so I know that these are the two that don't seem to be working. I'm going to pop it back in this machine though and give it a try, which we pop that in like so. And yeah, it's doing this weird blink code. Make it so you can see that. Hopefully that's visible in the camera. It's kind of like a, yeah, I mean, I assume that's an error code. Maybe? I don't know. All right, so this is the one with the flashing light, and I did just program that as the, you know, the set. And it actually had instructions on the web programmer said to put this in the kernel socket. And if you're going to use these other ROMs, you just run flying leads to it. I'm going to turn this on. Oh, no more flashing light. What the heck? And it works. So this is the one that has the dot on it. And it's functional now. I don't understand. I don't understand. So I'm gonna try to program it with the web programmer. Okay, so I'm just flashing this with the actual file I downloaded from Zimmer's, not the set that was part of the programmer here. And let's see if this works. No, it's flashing again. What the heck is going on? Why? I don't get it. Here's what's confusing to me. Okay, so this is it. So if we hit reconnect, you can just make sure this is the one. Okay, so that's it. It's currently loaded with 901.227.03. And we can look at the config and we can see it's set for 2364 CS1 active low, and the file name is, you know, kernel 901.227.03.bin, which is what I would expect. Now, what I did to make it work is I went to pre-built image and I just selected C64 set, this one. And it says here, it's a set of all of the ROMs you need. Put it in the kernel socket. You can run the extra lines, like for this chip select for basic and character to the X1 and X2. And this SD.RR image jumper select requires all open, so no jumpers installed. Okay. I hit program. This is all I did. And it's done. And there it is. It shows the set. And we can take a look at the device details. And the first ROM that's in here is 901.227.03. There it is. Active low. I don't understand. So if we unplug the cable, turn on the computer works. And it's not flashing. And so it's not damaged. It's like there's something with the programming that doesn't like work as I would expect it, at least. Now what I'm going to try, I'm going to put this third one into the 64. This is the one that just worked. And I'm going to try to program this with the kernel ROM, just the single kernel ROM file. I want to see if it misbehaves in exactly the same way as the other ones. Well, or at least the one with the flashing LED. That didn't make sense to me. Okay, so it's now programmed exactly like I did the second one. No flashing LED. Oh, and it works. Oh, none of this makes any sense to me. It really doesn't. So right now I do not have the set on here. In fact, what I can do is I'll just shut this off and I'll program this with JaffyDOS just to show that it's programming with a single ROM, which I've just done. So JaffyDOS is on here now, the file that I had in my Google Drive. And there it is. It works. So what's the difference here? Why does this other one, the second one, that has that weird flashy power LED sometimes, work when I program it with a set, but not when I program it on its own? Is there something different about these devices? Like, are they different revision? It says Fire 24 right on the top there. Okay, so that's the one that has JaffyDOS on it. I'm going to go back to the other one. This one's got kernel ROM on here right now, or it's got the set, or I don't even know what's on here. I think this is the one that's giving us the black screen right now. Or is it? Okay, no, it's working, but I think it has the set on there, or I don't even know what's on here. Let me try programming this with JaffyDOS. Okay, JaffyDOS is on there. I just programmed it with the exact same firmware that's on the other one. Oh, and it works. But I didn't do anything different. I did not do anything different. Yeah, I don't know what's going on. I don't know. But what I do know is this thing seems to be working right now. So that means I can program it with the XT-ROM, the diagnostic ROM, and we can try to get the XT or the 5150 actually booting now. So I'll move the 64 out of the way. And I just programmed this. This is the one that has the dot on it, the one that wasn't working. I just programmed this with the XT RAM test, the RAM test I actually want to run on this, not this other super soft ROM, which I totally loathe and hate using. Take the floppy controller out, so I don't need that right now, and it's just in the way. So let's get this out, and let's try this again. Okay, so it's in there. This is the one that was just working on the 64. Just move this floppy controller out of the way so it's not touching anything. Okay. All right. Pin 1 in the correct position. It's in there all the way. Oh, I need to switch over to CGA so you can see what I'm doing. So I'll switch the input there. Wait for this to come up. And there we go. Here we go. 3, 2, 1. And we're getting that flashing light again. So what's going on here? What is freaking going on? And that flashing light that this is giving us now also was doing it in the 64. I mean, I can try programming in the 64 set. Obviously, that's not something that's functional in this machine, but let's just try it. I want to see if we, get the flashing light or what. Okay, so right now I am programming this with the 64 set, the one that kind of made it work again on the 64. So it's the 64 kernel ROM. No, it's doing that blinky blinky thing again. So it's very unhappy about being inside this computer, obviously. It's something it does not like at all. Huh. And I mean, I suppose it killed the first one. And as for this one, I don't know if it's still going to work or it's going to be unhappy. Pins are fine. It's not bent up. Let's grab the 64 and put it back in here. It's currently loaded with a 64 kernel image. So theoretically, if I can get this into the socket, there we go. Theoretically, this can work unless it's somehow super unhappy. We're back on the retro tank while we're waiting for it. Here we go. Yep, blinky blinky. Okay, black screen. So turn it off. And I'm going to program it again, just the way I've showed you. Just going to go to set, pre-built set, and pick the 64 set. Nothing fancy. And I'm just doing it right now. I'm going to hit program. Something about the IBM like completely freaks this chip out. It makes it not work. So did it kill it? I mean, it's not flashing now. And there you go. One thing I'm curious about, let's take it out of the 64 while it's working. I'm going to put it into the IBM and then see if it starts doing the blinky blinky. I'm not going to change the programming. I'm just going to leave the 64 kernel image on here. And then I want to see if I put it back in the 64. Does it still work, or does it get somehow corrupted just by being inside the IBM? I've got to give it the old shove to get it into the socket. Oh boy. There we go, it's in. Okay, make sure it's lined up properly. Yes, it is. It's doing the blinky blinky. Okay, so yep, it is not happy about being in the IBM. Something about this is incompatible somehow with the IBM. And we'll put it back in the 64 now. We'll see if it somehow corrupted it by being in here, or being in the IBM, that is. Okay, there it is. Oh, the light's solid though. And it works still. The chips that go in the IBM are the same exact ones that go in the kernel socket, like in every way. So case in point, this chip right here, you can see right there, it's a 57C, 49C. And if we take a look at, oh, right here, well, there's a sticker over it, but this Jaffe DOS chip is the exact same chip. I mean, you see the 35? They are the same. The part number's on the bottom too. 57C, 49B. Okay, this is a B and that's a C, but whatever. That's just a revision number. These are the same chip. They program the same way. So this works in the 64 kernel socket. This works in the IBM's ROM socket. And yet, I can't get the One ROM to work, but the One ROM works in the 64 and not in the IBM. So it's super confusing to me. All right, so what I need to do now is I need to get up my EEPROM programmer. It takes forever to boot up, and it's a pain to use because I got to hook up to the serial port and stuff. So I got to use that to get the XT RAM test loaded onto one of these EEPROMs so I can use it in the IBM. Since I would normally just use my little adapter here, but it doesn't fit. It doesn't fit in the freaking socket because of the clearance of the disk drive there. So I got to program that up, figure out what's wrong with the RAM, which is what I initially set out to do with this video. Fix this computer so it can work. And I'll talk to Pierce about figuring out why one ROM's not working in it and let him know that one of these is dead now. I assume it worked and it got damaged somehow in the IBM, somehow. I don't know. And I need to figure out what that flashing is. So, okay, anyways, time for a break. I'll be back. All right, it's the next day, and I've had some conversations with Pierce over Discord and figured out a bunch of stuff. So I was obviously really on the struggle bus trying to get the One ROM working in the IBM 5150. And I was running into a couple different things that were really making it difficult for me. The first thing is the one with the pins on it, the very first one I tried, it turns out that I actually physically damaged this actual One ROM. And it wasn't the computer that damaged it, it was me damaging it. When I put this into the computer, it looks like I used a tool. I was actually using this, and this is not sharp, it's kind of blunt. I was using this to push this down into the socket because it's so hard to get into the socket, especially when I had that floppy controller in there. And I didn't really realize this, but these PCBs, even though the PCB is relatively thick on here, the traces are really, really thin. That's because this uses tiny little surface mount components, and simply pushing on it with this rather blunt chip lifter tool actually broke a few of the traces that go to a couple of the pins. So Pierce actually came up with a new firmware that should allow us to remap those pins to some of these signals that are on these pin headers here. So maybe I can get this one working again. That's the beauty of having a software-defined ROM. Now the other ones that I didn't physically damage, the ones that were giving me the flashing LED, that appears to be some kind of incompatibility with the 5150, the Rev A version of the board, which I have here, that we don't understand yet. But Pierce told me that when you get that weird flashing LED situation that these were doing in the computer, think of it like a failsafe or a limp mode, and that's where the microcontroller, the firmware on it, doesn't really know what to do. The LED is driven from one of the GPIO lines on the microcontroller, so it is software controllable, and that's sort of telling us that the thing doesn't know how to work. But the strange thing is, Pierce tells me that it would do that, for instance, if it can't read the flash. But while it's in the IBM, we turn the power off to the IBM, we plug in the USB cable, it's able to read the flash. We can program it, everything works fine. So we're not sure what's going on there. And then the weird thing is when we take it out, after I flashed it in this machine, I put it in the 64, I mean, you just watched. It would flash into 64 and not work either. And it would only work when I installed the full set of ROMs onto it, which apparently writes to more of the flash memory than just installing a single AK ROM. So we got a lot of mysteries when it comes to these devices and using them in the IBM. They don't seem to work. So right now, the 5150 is not going to be compatible with the One ROM, at least this Rev A version, and that's as of this date. But looking at the schematics of this Rev A motherboard, there's nothing out of the ordinary. I did check, off camera of course, that the power supply was giving nice solid 5 volts. It is. There's no overshoot or anything like that. It looks perfect. I even hooked up my extra power supply, the one that I use for normal bench testing, this one. I hooked this up to the motherboard. That didn't change anything at all. It behaves exactly the same. As I said, I was running into a whole bunch of issues there that were really causing me to be on the struggle bus. So what I want to do right now is I want to take the one with the pin headers, the one I physically damaged, and I want to try to put bodges onto this so I can make this work again. It won't work in the IBM, but it should hopefully work in the 64. So let me quickly modify this up as Pierce just described for me to do, and I'll flash the C64 kernel onto here and see if this one works. Okay, here's the ugly bodge that I just did, and it's just temporary. If this works, I will remove the pin header and actually put some proper bodges on there. We reuse the X1 and the X2 pins to create these connections to these two pins that I have the break to. The break is right there. It's very hard to see. Pins 23 and pins 22 are address lines, and when this was plugged in before, well, it wasn't getting the correct address line signals, and therefore, it wasn't serving up the correct data. That's the beauty of this type of thing. It's software defined, so all of these signals, including the bank select stuff and the X1 and X2, are just GPIO lines on the Raspberry Pi, along with all the other pins, except for the voltage pins, of course. And that means we can reassign them in software to do different things. So we've lost the functionality of X1 and X2 on this one, but if this does work, then this is still a working device. So let's get this into here, and we'll have to program it up with the kernel ROM, and we'll see if it can work in here. Now, I did inspect this to see if I had any other damage on it, and I didn't see any, but it's quite possible there is other damage. So Piers is working on a diagnostic ROM that we can plug into this once the USB stack stuff works. And that should give us a better view into if all the other signals are working, like all the other address lines are hooked up in the data line. Theoretically, with correct diagnostic ROM on here and a USB connection, with the system running, we should be able to see activity on all the data and address lines, especially if we put this into, say, the character ROM socket or one of the other sockets. And here's the schematics for the Fire 24. That's the one we're using here. And you can see all the data and address lines. And there's the X1 and X2 chip enable lines. There are those select lines. These are all GPIO signals that just go directly to the Raspberry Pi Pico MCU. So therefore, like I said, reassigning these in software, trivial. I mean, Piers had to do it for me, but he was able to do it pretty quickly and easily overnight. I talked to him about this problem last night when I went to bed and woke up in the morning. He'd already created the new firmware. And he also modified the web programmer to support this reassigned thing. Okay, it looks like I actually already have this program with the set. So the problem is the firmware that's on here is the wrong firmware, the one without the remapping. Yes, we now have this one, E80B01. This is the one that is for my broken unit specifically. So let's load this and let's pick the kernel ROM. There it is. It is a 2364 and active low, build firmware, program. Here's the moment of truth, everyone. Was Piers able to fix the damage that I created on this thing? Before I power on the 64, just need to unplug the USB cable. And here we go. It freaking works. It fixed it. Oh, that's amazing. That is so freaking cool. Software-defined hardware for the win. Unbelievable. That is so cool. That is freaking awesome. And what I'm doing right now is I'm just taking a screenshot of the screen and sending this to Piers just to let him know that that fix worked. So of course, you know what that means. I need to remove the X of shame from this device since it's not actually broken now. And I will have to modify this. I'll do this off camera in the future, just so I can take away those pin headers, do a proper bodge there. And I probably need to mark it in a way that will just let me know not to mix it up with one that is not damaged. Like it will never work properly with the stock firmware because it needs that swap. But obviously, with this bodge firmware, it freaking works. I just love that. Now, one thing I am curious about with this device is the whole time when I was using this one, it never did that flashing thing inside the IBM 5150. So just for fun, I'm going to leave it flashed with the 64 kernel. I want to put this into the IBM. I want to see if it starts doing the flashing just like all the other devices I've tried so far. Well, so far just one, because I didn't want to put that third one in. I was afraid it would ruin it. Because the whole time I've been trying to use this one when it had the damage in this machine, it didn't have those two address lines connected. And I wonder if that's somehow related to the flashing LED situation. Okay, I need to make sure that it's not touching the disk drives very close. Okay, it's not grounded to it. And those two pins are not grounded to each other. So pin 23 should be over here on this socket, and it is. And then pin 24 is, or pin 22 is that one, and that's good. Okay, so the question is, this thing is programmed right now for the Commodore 64. When I turn on the IBM, will it flash the same way the other ones were flashing? Now that we know this one works perfectly in the 64, and it currently has the kernel ROM on there. So I'm going to turn on the IBM, and let's see if it does the flashing. No flashing. Right, I think I'm going to try to program this with the XT ROM. It's super confusing. Why is there any kind of difference? So this is what we just programmed. That's that EABD, whatever, the special firmware. I will try the XTRAMTEST directly. Active low, build, program. Unplug this from the machine. Okay, all right, we're on RGB HDMI. Here we go, 3, 2, 1. You're kidding. So this one works. The bodged one works, but the other one doesn't. What? Now, that does kind of confirm, and I think I kind of mentioned this at the beginning, that the RAM problem exists on this RAM board. Interesting. Very interesting. Now, the reason why when I booted this thing up without the RAM board, we were getting RAM error is because the dip switches on this IBM, there are 2 sets of them right there. I think they basically tell it how much RAM you have, and the system is looking for that RAM. Well, because this card's not in there and it's looking for it, well, it's obviously going to error out. So there is not a problem with the motherboard RAM at all. The problem exists on that card. But being able to get this RAM test working, this was what I've been trying to do all along. Wow, I still don't, why does the bodged one work in this machine while the other one doesn't? It's super, super confusing. And the other one, which was this one right here, works perfectly in the 64, but it has that flashing problem in this machine. Total freaking mystery. Well, I just sent a message over to Pierce letting him know that this one works, the other one doesn't. If I hadn't have physically damaged this one, then I would have never even known there would have been any kind of compatibility problems with this machine, because I would have just used this one and it would have just worked, because it's just working right now. I'm sure that the firmware change we just made is not what fixed it. This one never presented the flashing LED on this machine, and the only thing that was broken was the address lines that go to pin 22 and 23. None of the other lines were broken. I know I tried these 2 other ones in the 64, but only one of these I tried in this machine, and it was the one that did the flashing LED. I was afraid to put the 3rd one in here because I was afraid that it might actually damage it, because I wasn't sure at the time what was happening. Now I know it's not a damage problem specifically. It's, I guess, something with that particular unit. Very odd. Very, very odd. Anyhow, the cool thing is here is I can put this RAM card back into this machine so we can see what exactly on this RAM card is bad. So let's get this into the machine here. So funny how easy that goes into the slot. Just goes in there. So simple and so easy. Okay, here we go. Okay, so it's detecting a bunch of memory. I think the limitation of 576K is the BIOS, by the way. It's not this RAM card. Though I'm confused. This card should only have 512K on it. And plus, so 576. Yeah, okay, that top of memory doesn't actually exist. Okay, there's our error right there. Nice. Ah, this RAM test is so useful. So much more useful than the built-in RAM test on the motherboard. So what I need to do is let this run for a while, and then we're going to have to figure out which bit that is. And we can look on the GitHub repo. It'll tell you which bit that will map to, or we can just actually, convert that into using the calculator to see which bit that is. But when it comes to this RAM card, I have to figure out which of the chips is bad. So I took a screenshot of this running so I can point to it, because I can't point to the video capture while it's running. Okay, so this part of memory right here, this is what's on the motherboard. We know that is good. Then that's bank 1, 2, 3, 4 on the card. I assume it's what's on the actual card itself, the chips that are physically on the card. And then theoretically, I don't know, let's call it E1, E2, E3, and E4. So this is the extra 512K, or the extra 256K, in addition to the 256K on the board. That totals 512, that when you add the 64 on the motherboard, that gives you 576K. And this top 64K of RAM isn't there on this machine. It just doesn't physically exist. Now, from my recollection, the original BIOS that's on this machine, it does not support 640K. It just cannot support it. I think they figured when they wrote it that it would only ever have an additional 512K in addition to the 64K that's on the motherboard of this particular version of the machine. This is the Rev A motherboard that only can take 64K on the motherboard. So like this section of RAM just can't be used according to the BIOS. But I'm assuming if I use GLA BIOS on here, that I could use the entire amount. I'd have to talk to Greg, the author of GLA BIOS, to see, how it works exactly when it comes to the dip switches that are on this machine, and if it is possible to use this memory. Now, figuring out which bit is bad is pretty easy. Just take 40 as the bad bit, type it in as hexadecimal, and then there's the binary representation. So this is telling us if this is the least significant bit, so that's bit 0, and that's bit 7. Bit 6 is the bad bit. Now, it's possible you could have multiple bad bits. For, like, say you had these bits that are bad, bit 2, 3, 4, 5. Bit 2 and 5 were bad, then it would show hex 24 under this EM column. But anyways, we know that the actual problem is bit 6. Now, on the IBM motherboard, it's really easy to figure out which chip represents bit 6 because we have schematics. You can just look at the schematics, see how it connects back up to the ISA bus, or to the CPU, that is. In the case of this card, we're going to have to try to find the manual, and hopefully the manual explains which bank is which and which bit is which column or row on the card. We'll take a look at the card in a second and try to figure out which bit is bad. But if we go back to the RAM test, it's now done 3 passes. This is doing March U testing. It's super robust. You can let this run for hours if you really want to stress test the system and see if you have like subtle errors, but obviously the only thing we have is just that bit 6 on this one bank. We know by just physically looking at this, these are 64 kilobyte by 1 bit chips. That means 8 of these is 64 kilobytes, and then you have a parity chip, and it says parity. So that tells us that this row of chips are the parity RAM chips, the 9th chip for each of these banks. Now the thing is, we don't really know if this is bank 0, 1, 2, 3, and if what's on the card down here is 4, 5, 6, 7. Or perhaps logically you would think this is 0, 1, 2, 3, and then these banks, which would be 4, 5, 6, 7, are not there until you plug this thing in. The thing is, it's possible due to the logic that's on here that plugging the card in reassigns it where these become the primary banks and that is the secondary banks on the backside. Totally possible. The other thing is when you're laying out your RAM chips, we know this is parity because it says it there, so that's the parity row. But then this could be bit 0, this row of chips could be bit 0, but it could be over here as well. That could be 0, 0, 1, 2, 3, 4, 5, 6, 7. And then that would mean that this could be bit 6 and probably on the bottom side too, since the bottom side, the layout looks identical, right? So that could be 6, but the thing is, this could be 6 as well. This is why having schematics is so important, because we have to kind of think about how the designers wanted to make this and try to understand their thought process. And the problem is there were just multiple ways to do the same thing. I can pretty much make the assumption though that this is going to be bank 4, 5, 6, and 7. And it's going to be what's on the card as the primary bits. We can tell if we just take this card off. So I'm going to remove the little standoffs that are on here. That's not the right screwdriver. We'll get a better screwdriver. But if we take this card off and then we run this card again, if the bad memory is one of these banks, then obviously, well, we'll know very quickly, right? Because the error will go away. Lift this out. There's our chips. Oh, empty RAM. Interesting. I don't think that's the problem though, because we know from the RAM test, look at this. I've already changed out RAM chips here. Oh. I've changed out a bunch, or someone's changed out a bunch. There's a whole lot of stuff on here that's mixed and matched. Okay, well, there's obviously been RAM problems on here, and it's been these TI chips and not the MT. If it was an MT 4164, I would suspect they're problematic, but these are the 4264s. You know, they're functionally the same. It seems that these are more reliable. That's just been my experience in the past. But we saw on the screenshot that the bad bank was in bank 1. If this is like 0, 1, 2, 3, then we know it was in the second bank that's on this card. Because the first bank itself, 64K, is on the motherboard. Then there was a good one that was on this card. And then there was the problematic one. And then there were the rest of them. So my assumption is, because we don't know if like this is bank 0 and that's bank 3 or vice versa, it's going to be one of these two middle banks. And then again, like I said, it's bit 6, which is either going to be these two or one of these two chips, depending on which bank is which. Or because we know these are parity chips there, it says parity there as well. This is going to be 7 and this is going to be 6. So it's either these two chips or these two chips. So I'm just going to put dots on the chips that I think are the problematic ones. And we will go from there to try to figure out which is which. Now these are all in sockets, so it's very easy for me just to pop these out. I could take them out, put new ones in, and we'd have this fixed really quickly. But I'm just trying to show you the process I would go through if, as an example, the chips were all soldered like this. Then you would have to figure it out unless you're going to start desoldering a whole bunch of random chips. First thing we need to do is plug this back into the computer and see if the RAM check still detects the RAM error in the same exact position and it hasn't moved around because we removed this RAM expansion card. One thing we have going for us is that these AST RAM cards were quite popular, so they're pretty well documented. So we can definitely find the manuals for these. But there are plenty of RAM cards that did exist out there in the day that aren't documented because they just were smaller companies or Taiwanese companies, and you know, there's no way to find the documentation. So you kind of have to figure it out yourself, which is what we're trying to do here and what I'm trying to demonstrate here with this process. Okay, before I turn on the computer, let's review what it looked like first time. It's good to take a screenshot. What I am anticipating is we will have all the way up to bank 4 working, and then E1, 2, 3, 4 are now going to have all FFs because they don't exist. The good thing about this RAM test, by the way, is I don't think it matters how the switches are set on the motherboard at all, although it's technically possible that the switches on the motherboard do determine the way the motherboard routes the signals to the ISA slots for the RAM access. It's quite possible. I'm not 100% sure of that. But I know as it sits right now, because this was working, it should still work. And I'm anticipating that we're still going to have the RAM error in the exact same position. It won't disappear. If it does disappear, then we know that it reallocates these as bank 1, 2, 3, 4, and the error exists on this card and not that card. But anyways, that's what I wanted to see. So first of all, it's going to go through and it's going to do the check. Uh-oh. Appears to be what I suspected. Oh, unless it hasn't found. Okay, there we go. Okay, here's something that's very interesting, by the way. Notice how it did not detect the 40s on the first pass. It came later. And that's because the initial test it's doing, I would have to look at actually what it's doing. Let me reboot the machine. I want to see what it's doing when it goes through that first pass where it doesn't even detect the RAM error, but it goes through various phases and it says what it's doing. Okay, so it's doing March U01. And that one goes through that whole bank and doesn't even detect an error. So it just sort of shows you that certain types of RAM tests don't always detect errors. And that's why March test has multiple phases. And now it's in O2 phase. So it's going through, it's doing like a different phase of switching the bytes. Now it's in the third phase where it's going backwards. So it's kind of reversing the bytes, or the bits, I mean, and so on and so forth. All right, well, anyhow, point being is the bank that is bad is on this card. It is not on this soldered card. So that's a great first step. So that tells us a lot about what we need to know. Now, the next thing is how do we figure out which actual chip is the problem? Well, that is a little bit more of a problem. And obviously going to the documentation might reveal quite a bit. But I have a hunch. Based on the fact that these MT chips are all the same, and then all of these other chips, which are super random, were installed after the fact. That tells me that most likely this is the first bank, bank 0 or bank 1, if you're going to call it 1 through 4. And this would be 2, 3, and 4. That's the logical way they would lay this out, the engineer who designed this card. So if you bought this card, it originally came with just 64K of expansion RAM. With this in the IBM 5150, you'd get 128 total. And then you could optionally start adding memory. Memory was very expensive in 1982. This card is from 1982. In fact, if you look at the date codes on these chips, 1982, 28th week. So yeah, at that point, this memory would have been very costly. This thing, which also looks has 1982 chips on it, this has 512K. 512K 1982? That would have been unbelievably expensive. Anyhow, look at these chips. 1982, 6th week. Now, I don't know. Obviously, this stuff's been switched around. I've had this machine a while. This must have had bad RAM on it, and I'm assuming that I did some of this swapping that's on here. But for me, because the predominant chips that are on these other banks are these TI chips, which, well, frankly, look very, very similar to these, 8249. These are 2 or 20 NLs, and these are 20 NLs as well. It's interesting that this has had so many issues with these chips going bad, and yet these chips haven't seemingly had any issues. Anyhow, my hunch is this is going to be our bank that's affected, and it's going to be one of these two chips that is the problem. But again, it doesn't quite tell us which is going to be the chip. I'm looking for any marks on here that might help us identify. So there's U1, U9. So it kind of tells me that this is probably bit 0. This is 7. That is going to be the parity bit, the extra chip. So that would tell me for here that this is going to be our problem chip. And I'm just going off the fact that the engineer who designed this thing would have made the first marking for the IC, they would make that the first bit. And then they would make this the parity bit over here, U9, because it is the 9th chip. Let's look at the backside to see if there's anything that identifies anything. No, there doesn't appear to be anything. Just says AST Research 1982. Now you might be thinking, hey, you could just go from like the data line that's on one of these chips over to the ISA connector, and that would help you figure out like which data bit maps to what. If you had a very simple RAM card, say something like this one here, this is the one that I built myself or designed and built myself. Yeah, that's the case. The SRAM chip that has 512K is just connected directly to the ISA connector. So that would be easy to tone that out if you're trying to figure out which data line goes to what data line. But this board has a bunch of stuff happening on it. Obviously, this has got transceivers on here. So there's an LS245, which almost certainly the data lines from this go to that, and then this goes to the ISA connector, because there's going to be other ones. Let's see, that's a latch. I mean, most likely, you know, this is doing serial, parallel, clock calendar, and stuff like that. So most likely there's going to be other buffers and stuff. Yeah, there's another one right there. So it's quite possible like all of this stuff goes through that buffer for the 8 bits, the data lines that is, and that this one is handling the RAM. Now, technically, it would be possible to try to see if like this is the 245 that's hooked up to the data lines on these. I mean, we could do that real quick, actually, and then we could try to see if the other side of this makes its way over to the ISA connector, and that would give us a definitive answer on which bit on the ISA bus goes to which RAM chip, because we know it's bit 6, very specifically, that's bad. Let's just give that a try instead of me trying to guess. So I'm just going to go to that pin, and I happen to know that is going to be a data line. Data lines on these chips are typically, yep, these two. One's in, one is out, but a lot of designs like this board, they're just connected together. So let's check over here on the 245. Not that side. How about this side? This is a bidirectional chip. All right, so this chip goes to there. I'm just going to put a little dot on this LS245 right there so we can remember where that is. And now I got to look up the data sheet for this chip, or the pinout for it, to see which data line that connects to. So this has 8 bits on each side of the chip, and they're connected together. But I think they're offset, if I recall. Yes, there it is. So there's the A and the B side. So we're on the second chip from the bottom. I know the dot's kind of in the middle, but it's the second pin from the bottom. So data line 7, which, if you think about this, like data line 0, 1, 2, 3, 4, 5, 6, that would be pin 12, right, for B7, and then that would be data line 8. And then that makes its way over here to pin 8, A7. So B7 and A7 are hooked up together. So depending on which way this chip is configured to connect, you know, which direction, those can be connected together. So now we need to trace where pin 8 is going to the ISA bus to see if indeed that's data line 6. And remember, this is labeled 1 to 8, and we're talking about data bits 0 to 7 for an 8-bit system like this. All right, so a quick look at the ISA connector. It's D6 we're looking for, so it's the third down. Now the problem is it has X and Y, and it can be a little confusing when you look at the card, like which is which. Well, one way you can tell is the ground pins are on the other side. So if we look at the first pin on the top side here, which I'm pretty sure it's going to be the back side. So I think the third pin down on the top side is going to be 5 volts. And it's going to be relatively easy for us to see that, because all we really have to do is go to a chip and go onto the 5-volt pin, which is going to be this top one right here. And let's see where that is on this connector. Ah, it's on the back side, I think. Okay, that's good for us. Yep, there's the 5-volt pin right there. It's on the back side. And that means the ground is also going to be on the back side as well. It's going to be this pin and this pin all the way over here on this end. Oh, well, can't get to it. Here we go. There it is. All right, so back on here. So we know the plus 5 volts. Oh, you know what? I might have been confused because there's plus 5. It's on. It's twice. Okay, so I think this signal or this signal is going to be potentially our data line 6. How can I verify that? I don't know. We'll just try both. First, let's start over here. I'm just going to hold on there, and I'm going to look for any pin on this 245 that has the continuity to that. Nope, nothing. Let's try over on this side. And let's see. Oh, there it is right there. Oh, okay. It is the pin that I thought it was. So it's this pin right there. That goes to data line 6 on the ISA bus, which goes to the CPU. And we know from the data sheet on the LS245 or the pinout that it is this pin on this side, the one with the gold mark, that is going to our bad chip. And we know it's this chip right here. I mean, it's going to all these chips, right? Because these are all in parallel, this whole column. But we know that it's bank 2 specifically. So I still don't know for sure which is bank 2, but I'm making the assumption, remember, based on the chip markings, that this is the second bank and this is the third bank. But theoretically, we know it's one of these 2 chips that is the problem, if the banks are organized in a way that isn't as what I would expect. I'm guessing right now, where's my marker? I'm going to put 2 dots on this chip because I am positive that it's going to be that one. That is the problem specifically. Now, as an example, if we ran this RAM test and we had that bad bit in all the banks, and say we had the RAM card or the expansion card in there and it was on those as well, well, that could tell us that one of these chips had gone bad and was killing the data bus. Or it could be this transceiver that was bad. But if the rest of the card was working properly, that would tell us that the problem of that data line is on the RAM side. So remember, the right side of this is all facing this RAM. The left side faces the rest of the card and the ISA connector. And I'm pretty sure that all of this stuff is connected through this bus transceiver. So if this were having a problem, it could be this bus transceiver that was bad. It could be, something in this section over here that's bad. But they separated this card into like 2 functional cards. In fact, like if you remove this LS245, then my assumption is none of this would work anymore, but the RAM section would probably still work perfectly. I think this is our problem right here, this guy with the 2 dots on it. And that's from my guess that this is the second bank. So I pop that out. I'm going to look for a new RAM chip to stick in there, which I think I got some over here. Which I think I have a replacement. I have plenty of replacements. Here we go. Look at all these. I'll put another TI chip in there. Why not? I kind of went through all my chips that I had. I mean, I have lots to choose from. These are all compatible chips here. Yeah, well, not these. These are 4116s, 214s, but I got loads. Oh, look, an MT RAM. How about we put one of those in? It seems to be a lone wolf on my little sheet here. Although, I hate using MT RAM. I don't know. Let's just put it on anyways. Whatever. I'm just trying not to break up the big sets of RAM chips. I also have this random Oki chip there. Could use that one. We'll use the MT RAM. It's kind of crusty, but looks good enough. In that goes. So yeah, another weird random chip. Back into the system. And here we go, 3, 2, 1. Turn this on. See if we fixed the RAM error. I'm very confident that that was the fix. Remember March test 1 doesn't detect anything? Now it's going to have all Fs. There we go. Yeah, March 2 was detecting that problem. Nice, nice. Now, one thing that's interesting, I noticed I edited up the first part of this video. When I got the parity error on this machine originally, when I had this card in there, just when I first turned it on, very quickly, it did flash a RAM error code. And it's quite possible that the stock IBM BIOS actually would have told us exactly which chip was bad. I mean, you have to do a bunch of decoding because it has an error code. I think it's like 201 is a memory error, and then there's some hexadecimal stuff. You got to kind of decode it to figure out what's wrong. It seemed like it was detecting it, but it was weird because then DOS would start to boot, and then it would just immediately give a parity error. So my assumption is if it detects a RAM error, it doesn't just continue letting the system boot, that it will actually kind of stop using that part of the memory that has the error, like it will only use the part that's below it. But I don't think that was happening. It didn't seem that was happening. What we need to do now is restore this card back to having all of its memory, like so. So the RAM expansion is back on, and now we need to run that RAM test again. Just let it sort of do its thing, see if it is all working, which I presume it is. I got to find that TI chip because this chip deserves X of shame. Another bad RAM chip. Unfreaking believable. And yeah, it looks like it is all detecting the memory as expected now, which is cool. Now, as for that top 64K of RAM, I was just looking at my RAM card, which has a little chart on the back to help you decode how to use it. Now, the RAM decoding I have on here is very simplistic, and it unfortunately is working in 128K blocks. So there is no way for me just to backfill that top part of memory. Although, what is this jumper JP2? I think when adding memory to this very top location, I think this JP2 tells it not to map into the upper 64K. What's it say on the top here? Oh, here we go. JP2, 128K UMB or 64K UMB. Is it possible that I could set that? So if I set it to fill this block, H1, and then I set JP2, must jumper JP2, then maybe it'll only add memory to the upper part. Let's get switch 5 on, disable. Oh, sorry, yeah, wait, it needs to be off. That's right, that's how this card works. I always get confused, and I designed it. So setting these on actually disables all these other banks. So the first thing we can do is we can put this in the system with the RAM card removed and see if it added memory up to the top of the memory space there. It would add it between 512K and 640K. Of course, that's after we know the memory works. Yeah, it's already done 2 passes and it is working. Okay, cool. And I'll swap over to this card. We'll see if it's adding memory to where we expect. This is going to be adding 128K, not just 64K. But this test is great because it will be able to tell us, even though we have non-continuous memory, yep, there we go. So it is in the upper chunk, just like I suspected. And there's a LED on the RAM card, by the way, that turns on when it's testing it. So I think that's kind of cool. So it's off right now as it's in other parts of memory, and now it's on. Okay, so it's working as expected there. Now the question is, will JP2, if I set this, JP2 1, 2, or 2, 3? So I'm gonna switch this to 2, 3. And let's see if now it's only in the upper 64K. If that's the case, then I could use this in combination with that other card. Let's see what happens here. Because it will no, that does not work as expected. Okay. So I cannot use this card. The decoding logic that's on here is just not sophisticated enough, unfortunately, just to map 64K anywhere I want. It works in those 128K chunks. And yeah, so oddly enough, that jumper, I think it works only in the upper part of memory. And I'd have to go to the schematics to see exactly how that works. I don't quite remember. It's been a while since I designed this thing. Is there a date on here? Yes, 2019. Gosh, wow, 7 years ago? That's, well, not quite 7 years ago. Okay, well, I think I can put this thing kind of back together and we can reflash the BIOS, put the XTID in there. Let's reflash the BIOS, and I gotta get the USB cable hooked up first because obviously floppy controller makes it hard. In fact, just the RAM card makes it hard to get to the USB connector. So we can reflash this BIOS back to something much better. I still have to use this special profile, but we can put something else on here. Now, incidentally, this still has bank selection capability. So you could load up to 16 ROMs on here and you could select them using jumpers on it. The thing is, the web flasher cannot do that. So I've talked to peers to figure out a way to do that. But the reason why this is useful is because I could put a regular BIOS on here, and then I could have the XTRAM BIOS on here too, the RAM test one, and I could just install a jumper on this thing on one of the leftover pins, and then that would allow me to run that BIOS on demand. Plus I could put that other diagnostic, the Supersoft one on, the one that annoys me so much, but I can put it on there because it still can test, certain logic problems, I suppose, on the motherboard, theoretically at least. Anyhow, it's the 8P one. This is the GLAD BIOS, just stock build, that is for this machine. So active low, build, program. So with the RAM card back in there, I haven't put the floppy controller in, but let's just see if GLAD BIOS is able to see all the memory and is working properly with this machine. Yep, there it goes, cold boot. Should be 576K. There it is. It's detecting one COM port, one parallel port. All right, floppy drive is plugged back in. So everything is back to the way it needs to be for this thing to boot. Let's give that a try again. And then if this works, I'm probably going to go and replace this. Yeah, that's noisy. Yeah, no more errors. I'm probably going to replace GLAD BIOS, and I'll replace it with my super fast one. There it is. Free game boots. It works again. Nice. Absolutely nice. But as it is, you can see that just the very bone stock GLAD BIOS in this thing, we turn it on. I mean, look how quickly it will post compared to the stock one. And it tells us what's happening, like the RAM and all the parameters and stuff like that. So it is great. It is so much faster than the stock BIOS. Yeah, the IBM BIOS. Yeah, it was reliable, business computer, blah, blah, blah. But yet, obviously, this thing could benefit from a nice speed up. And that's exactly what we have here. So here's my glafast.asm, which is my sort of performance optimized version where I just disabled every kind of checking. This works well on a reliable computer, but with machine with RAM errors, potentially if more RAM chips fail in this thing, this might be unpredictable what's going to happen, because it's not even going to bother checking the RAM. It's just going to size it and then boot the system. But let's go for it anyway. So we got to change the architecture type here to 5150. So there's max boot speed, and there it is. I have the refresh set to 1024, that's the DRAM refresh, and that having this set higher than stock, which is 18, results in a measurable improvement. But I know Jim Leonard did some diagnostic or did some comparison tests and benchmarking and found that 256 is pretty much the upper limit of where you start to get, gain performance. You can go to 1024, and on the XT, I was doing some testing after I made the last video, worked totally fine, but you don't really see performance improvements. But having this at 256 versus 18 does give you a performance improvement. It just refreshes the DRAM less often, but IBM's original setting of 18, which is this, 66,287 hertz, it's really too frequent. So raising this up slows it down, doesn't refresh the RAM as much, but generally the RAM is going to work fine. Anyways, I already have snow removal set to 0, so it's the fastest mode, which of course, when you have a CGA card without snow, that's what you want to use. Everything else is disabled, including the RAM test. And I do have those other optimizations. You have to watch the video where I talk about all the optimizations that speed up the boot process even faster. It basically makes the computer essentially instant on. And if you don't have a hard drive controller in there and you set switch 1 to be on, it will boot into BASIC in like 1 second, a little over a second. Super, super fast. So I've edited that file. We need to make it. So we hit make. That's interesting. There are some errors there. There it is. If not PPI boot and mask PBTT boot to turbo 0 wait state mode. It's so funny because this whole section that's talking about this line, this is in like a V40 initialization thing. And I'm pretty sure, I'm not, why is that getting even called? All right, what I'm going to do is I'm going to delete GlaFast, and I made a copy of it first, and then I'm going to copy the stock unmodified GlaBIOS file into the position, because I just want to see if our problem is going to ask to reload it, which is fine. This doesn't have any of that max boot speed stuff whatsoever. I just want to make sure that this assembles correctly. So we just have to fix this architecture type to the 5150 again. And let's see if this makes. Okay, that makes with no issues, no problem, great. But what I did when I have this max boot speed stuff configured, if I go find that section, I'm just going to replicate that over. So all of this stuff here is set. So I'm just going to put this at the very end of this whole configuration block. It's going to override any of those variables that are set up above. So if we save that, and now we try to assemble, no, this works. So there's some other change that I made somewhere in here with this max boot speed thing that causes this issue. Just having these changes in here alone are going to speed this up dramatically. It won't be quite as fast as my hacked up max boot speed BIOS, but this will be much, much, much faster than the original BIOS, where it's, doing the nice things like it's checking the RAM and stuff like that. This is just essentially going to skip everything. Okay, so now 2:30 p.m., that was right now, so perfect. Active low, build, and program. Okay, turn this on. Okay. What happened? Did we lose video? There's no video. It beeped. So we're getting a beep, like a post beep, but no video now? Are we on the right input still? Yeah, I didn't change anything, right? Yeah, that. All right, I just put back on the stock XT GlaBIOS ROM. And that works. Okay, so we know everything's working for the connectivity there. So there's something going on with my assembled copy. All right, let's just make sure we're using the source code right from the repo. So this is the zip file I downloaded. I'm going to copy this. I'm going to delete the GlaFast, which is the thing the make command that I have in here is what it uses that file. And we're going to use glafast.asm. So now this is completely stock. If we go into the text editor, it's going to tell us, yeah, it has to reload it. So now we just need to switch this over. So it looks like this defaults to turbo. So I just have to switch this over to 5150. It's 8088. And I'm just going to put turbo none. I don't think it matters, but I'm going to do that anyways. I'm going to leave everything else totally stock. Now I'll make it again. No errors. Perfect. I'm going to rename it to stock so I know with the web flasher for the One ROM that I'm actually loading the correct file. So here we go, 5150 stock. That's the one we just assembled. Active low, build, program, and here we go, turn on the system. Okay, it works. Cool. So the file I must have been working on, I must have had some changes in there, or I had done something, obviously. Without question, I had done something. So now we're going to do this again. I'm going to copy all of these to basically make it as fast as possible. Go all the way down to the end. Go down to the build option end here, and we're going to add this stuff in here just to speed it up as much as possible. We're going to hit save. We'll reassemble this. No errors. We'll rename this GlaBIOS 5150 Fast. We're going to plug in the USB cable. We're going to open up our fast file. Pick active low, build, program. There it is. Unplug the cable. My assumption is this is going to work now. It does not work. And it sounds very unhappy. And I turned it on this time and it's not making that beep. It's just not doing anything. It worked a second ago and now it doesn't work. So I'm going to stop the camera and I'm going to go chat with Greg about the GlaBIOS and see maybe one of those options should never be used with the 5150, and I'll come back to you. Okay, I'm back and I have everything all figured out. So there is a bug in the GlaBIOS code, and actually this is something that's funny. Greg and I figured this out last time I was working on this, which was months ago, and by this I mean the super fast BIOS. I've loaded up the original source code, and what I had done is in my little parameters that I set to try to speed up the boot process, I had set RAM test none. I set this to 1. Turned out that that was the problem that was causing it to have that weird issue when I powered on the computer. And the weird thing is, if you take that ROM and you put it into maybe another motherboard, it's fine. If you put it into emulators, it's fine as well. Only happens on real hardware. And I think it happens on any real hardware too, not just the 5150. If we take a look at this RAM test none parameter and we just search for it inside the code, if RAM test none is not equal to 1, so basically if it's equal to 0, which means, you know, you're gonna run the RAM test, then it does a bunch of base RAM test and zeroing and stuff like that. But if you set it to 1, like I had set it to try to speed up the process because I don't really want to do any RAM checking, then what it's doing is it's skipping over this entire section. Well, after some trial and error and going back and forth and actually looking at my old code and also talking to Greg, well, it turns out the problem is you cannot skip zeroing out the base RAM. So the base RAM is the first 16K of memory on any PC. And if you don't zero that out, basically it causes the computer not to work properly. So the BIOS code that's on this computer now, that's running really fast and pretty much how I like it, it just has simply this section here. I just removed all of the RAM testing code entirely from what's assembled on this machine. All you have to have left is this halt beep routine because it's used somewhere else in the code. It's not going to be called for the RAM test anyways. And all we're going to do is we're just going to zero out the base RAM. And there's also this like floppy disk motor tick thing. I don't know what that's doing there, but for whatever reason it's there. If this section right here is removed, the system will not work at all. It will give that weird error where just beep, it goes crazy and freezes. Anyways, with that there, then we can look back in the top part of the code here, and I just did add back in the max boot speed stuff because I made a couple changes here and there elsewhere. But all of this stuff is set, which speeds up the boot process dramatically, and including RAM test none is still set to 1, RAM test long is 0, parity checking is disabled. All these other things are disabled. And I also have the DRAM refresh set to 256, so it's sped up. So there should be a performance improvement. And CGA snow is set to 0, which means if you use a normal IBM adapter, you will get snow. But pretty much any other newer, more modern CGA adapter won't have any issues. And then, of course, this is set for Arch 5160, somewhere up here. Yeah. Wait, there it is. 5150, I mean. So let me demonstrate how this works, like with those particular speed up routines. All the cards are reinstalled, including the XT IDE. I did flash the latest version of XT IDE BIOS onto here, but first I'll demonstrate booting the hard drive. So I can turn on the computer, beeps really quickly, immediately starts booting off the hard drive. Well, and unfortunately, XT IDE, it has a delay where it's waiting you to like push a key, and then so does the starting MS-DOS prompt, so it's all a bit slow. But there we go, we're booted up that quickly. Now, let's see, I think I have the MIPS utility on here. Okay, so we should get a performance boost on here versus the normal speed, which is 1.00, because of the DRAM refresh setting for 256 versus 18. I think overall performance should be like 1.05 or 1.0, 6 or 1.04, something like that at the very bottom. It's going to average it, all that stuff together. Memory to memory speed, obviously sped up a little bit. Yeah, 1.05. That's what you can pretty much expect with the refresh set 256. If you raise the value to say 1024 and the system is okay with that, you will get a tiny, tiny little improvement, but it's marginal. And of course, you're risking the RAM not refreshing and you lose bits and stuff like that over time. I've played around with this thing quite a bit. It seems to be totally stable without any kind of issues. And actually, if we go into here, what I also did is I copied on the XTRAMTEST onto here. And what this is, it's a DOS version of the XTRAMTEST I used to find the bad RAM chip on here. Because remember, this computer no longer has a RAM check when you turn it on. It just counts the memory and then moves on from there. So we can do load XTRAMTEST, and it will beep like that. That's normal. And now it's going to be running that RAM test. And what it does is it loads the code, because this has to run somewhere, it loads it into the CGA card. Normally it's in ROM, and it's running from ROM, and it doesn't need any RAM to work. Well, this is now running from the CGA card's buffer. Yeah, you can do that. You can run code in your video card. It creates lots of snow when you're using an actual CGA card, but on this CGA card, which doesn't have any snow, we don't have any problems. And maybe it runs slower because it's going through the ISA bus. I don't know. Either way, totally works, and you can just let this run. So if I suspect any kind of instability issues with this thing, then I can just run this test and let it sit there for a long time and just sort of, bake in. I mean, I'll be not surprised if we get more RAM failing on this AST RAM card at some point in the future. And I mean, it definitely worked this computer last time I used it. Incidentally, you can't control delete out of here. You're going to have to power cycle the computer. But luckily, it doesn't take that long to power cycle this computer now. Now, the funny thing is, if I hold down Shift, so there we are, booted into DOS. If I turn the computer off and I pull out the XT IDE card, okay, I'm going to leave it in. I'm just going to flip the switch to disable it, actually. That switch should disable it. When we turn on the computer, watch how fast the computer boots now. Okay, so it's trying to load the floppy disk. And actually, I forgot to alter the ROM. So my max boot speed stuff is not the same as I had on the XT because it tries to retry the floppy disk multiple times. Remember, I changed that to, I think, retry. Well, no retries. It tries once, and then it gives up and goes to basic. If I grab some disks and I stick in PC-DOS 1.1, and we're going to power cycle the computer. So this will be from a cold start. Watch how fast this boots. It's already loading off the disk drive right now. It is that quick. Look at that. I mean, it's fast. It is fast. There aren't all the optimizations I had on the XT one, so the max boot speed changes. It's probably a little bit slower. So I turn this on, and Alley Cat's loading. I mean, almost as quickly as the video appears, it says Alley Cat. Now, I forgot to remove the boot cold or warm. There was an extra parameter that I didn't set. There's Alley Cat. I have some more games, booter games on here, like this one here. Didn't really demonstrate these in the last video. So I'll turn the computer off. So totally off, cold start. It's already booting. I mean, it's so crazy how fast it boots. There it is, it's Pac-Man. F1, start game. This game, by the way, has pretty nice CGA color graphics, where the colors are better than what we're seeing there. Another booter game, so we turn this off. And this game that's loading definitely needs CGA graphics. Oh, and I can show you that, actually. It's because we can do color decoding. There it is. So, yeah, this is going directly to artifact color, which we can turn on by going to, what here, artifact color, on. I think the phase is wrong. I can't remember what phase is supposed to be. I think that's the right phase right there. Oops. So to play the game, press spacebar. So yeah, these booter versions, the early booter versions of this on the PC do need artifact color, but then you get colors like that. I mean, that's a whole lot better than regular CGA graphics, isn't it? Because CGA graphics is, looks terrible. And I think there's an RGB mode of this, but it looks, oops. I always do that. Let's reboot the computer. Look at that, it boots up so quickly. Oh, that's artifact color decoding. You can ignore that. That's just the RGB to HDMI. All right, yeah, if we push RGB mode, you can push escape, it goes to RGB mode. It doesn't look good at all, it looks absolutely horrible. I'm not even sure why they bothered with it. They should have done like a dithering or something better than what they did. Now, even this game would benefit, or is benefiting from our improved, what do you call it? The fact that the RAM speed is faster because of the refresh stuff. Anything you run on this that doesn't take direct control of the hardware and try to manipulate that stuff, which I'm sure this game doesn't touch any of those settings, like parity checking or the RAM stuff, it will benefit from the speed up. I mean, it's, you know, a small speed up, what, 6%? But that's still something, especially when you have a slow system like this, right? Okay, I've turned off artifact color and I put a different disk in. Let's power cycle this or turn it on from cold start. Do we want color? Yes. Here's another game. Look how quickly it loads. It's just completely wild. And there we go. We got Planetfall. I beg your pardon. And this also will benefit from the speed up, like I said. So there we go. This machine is freaking working. I just want to demonstrate one more floppy disk. This is formatted for DOS, but it doesn't have a system on it. I am curious how quickly the system will boot or to BASIC with the XTIDE disabled and a blank disk in there. Let's see how quickly it gives up. Oh, okay. Well, I formatted it with, as you can see, WinImage 6.5. I'm just going to put another random disk in here, one that I don't think is formatted. And let's see how quickly it goes to BASIC. Okay, so it is trying to read it. Okay, it goes pretty quick, but I think it does try to read it several times and it's not getting, you know, the sector that it expects or whatnot. And then it drops you into BASIC. So let me re-enable, well, let me enable the XTIDE card. So I just flip the switch. Now if we turn this thing off, back on, there you go, it's working. It's kind of annoying how slow it is. I think there might be a way to speed that up, probably by editing the source code. It's waiting for me to push like the A key to boot the floppy disk. If anything, I would like it just to try to boot the disk drive every time, just in case I want to use a booter disk on this machine and then fall back to the hard drive. But I'm not sure that's a setting that you can easily change. All right, well, there we go. That is the IBM 5150. It is back and operating again. It may not be the fastest computer around when it comes to turning on because I didn't apply all the optimizations, but now I have the One ROM in there and it's working. I have the one that's bodged or whatnot, and I can spend some more time, just I won't do it on this video, optimizing the ROM that's on here, you know, taking over those optimizations from the other XT version, getting them into here to get this booting as quickly as possible. And otherwise, there's no real difference between the speed of this machine and the 5160. They should work just as well. All that was taking this machine out of operation was this single bad RAM chip, and I expect them to be more in the future because there have been a bunch on that card. Probably would behoove me just to like swap all the chips out on the card, at least those 3 banks, the ones that have all the failing chips. Kind of weird, isn't it, that all the soldered chips are fine that are on that expansion card, all the original bank 0 or bank 1 chips are fine, and the motherboard chips, well, there's a few that have failed on there as well. It's so weird how those TI chips, there's like a period of time where the TI chips are ultra reliable or unreliable, and this machine came with all the RAM that's in it. That expansion card, the AST card, came with this machine when I bought it, along with the motherboard. The RAM that was on there was all original as well. And I think it took me quite a while early on to fix this thing because I didn't really know what I was doing. Plus, I didn't have the great XTRAMTEST that I could run to tell me exactly what was wrong. I would have been able to fix this thing so much more quickly with what I know now and the tools I have available to me than I did when I first got this machine. And then as for the One ROM not working, I'm gonna have to talk to peers to troubleshoot what was going on with the flashing LED thing. And I have more to test, so I'll try those in here as well in the extra socket that's in there. But the one that's physically damaged, I'm really happy that peers was able to get me new firmware that I could remap the pins and do little bodges to make that work again. So be very careful if you buy a One ROM. Don't push on the PCB with any kind of tools unless it's something that's designed to push on it, because you can easily damage the traces, which is exactly what I did. And it's microsurgery. They're so small, and I don't have a proper microscope and the right tools to fix that. It would be totally fixable to put little jumper links over where I broke the trace, but anyways, it's working, and that's all that matters. And I'm gonna leave that in this machine because it's missing the X pin, so I can't run multiple ROMs. But in here, that's completely fine. And once I figure out how to be able to flash multiple banked ROMs onto it, I will probably come back and revisit it so I can load this machine up, say with the XT RAM test in the actual ROM, because if the machine gets so screwed up with the bad RAM that it won't boot DOS anymore, then I'll need to run that in a ROM. So I can just put a jumper on there, or maybe you have a little toggle switch on the back of the computer to enable that ROM on demand, because I feel this computer is going to keep failing. Anyways, that's going to be it for this video. I hope you enjoyed my RAM diagnostic and hope you found it helpful. That technique should work with any type of RAM card on any of these PCs. And I really have to thank David Giller again for making the XTRAMTEST. It is a lifesaver, an absolute lifesaver. I hope you could see in this video how useful that is. And I think I've talked long enough. So huge thanks to my supporters and my patrons, and they make it possible to do this full time. And thanks to all my subscribers. And if you haven't subscribed, I'd appreciate it if you do. Comment down below, all the usual YouTube stuff. And I guess that's going to be that. So y'all stay safe, and I'll see you next time. Bye-bye.